So we're going to go ahead and continue on hypothesis tests with a little focus on type 1 and type 2 errors. Number 1, video arcades provide a vehicle for competition and status within teenage peer groups and are recognized as places where teens can hang out and meet their friends. The National PTA organization, concerned about the time and money being spent in video arcades by middle school students, commissions a statistical study to investigate whether or not middle school students are spending an average of over 2 hours per week in video arcades. 20 communities are randomly chosen, 5 middle schools are randomly picked in each of the communities, and 10 students are randomly interviewed at each school. So we're going to use this for questions 1 and 2. Some of you said, why is it phrased as parameter of interest? Could you elaborate on a parameter a little more? So the parameter is what we're concerned about. And in fact, they say concerned about time and money. Now, the study does not actually go into the money. It's really more concerned about the time. They're worried about middle school students spending an average of over 2 hours per week. So the parameter is the mean number of hours per week spent in video arcades by middle school students. Now, since it's over, that means we're trying to do research to find out if they're spending more time. So the alternate hypothesis is more than 2. The null is equals to. So we want to go ahead and use C. We're comparing an equals to a greater than. So the answer is C for number 2. Okay, so one of you asked, why is halting the production process when the braking strength is within specifications? A type 1 error. So let's go ahead and read the problem. A company manufactures a synthetic rubber jumping bungee cord with a braided covering of natural rubber and a minimum braking strength of 450 kilograms. If the mean braking strength of a sample drops below a specified level, the production process is halted and the machinery is inspected. Which of the following would result in a type 1 error? So we're worried about minimum braking strength of 450 kilograms. We assume that the minimum is equal to 450 and we're worried about it being less. So a type 1 error occurs when the first hypothesis is true. So it really is meeting the minimum, all right, of 450, but we think it's less than 450. So in that case, we would stop production, right, because we think the cords are not strong enough, even though they are within specifications. Number 4. Your plan to perform a hypothesis test with a level of significance of alpha equals 0.05. What is the effect on the probability of committing a type 1 error if the sample size is increased? So alpha sets the probability of a type 1 error. We didn't change alpha, just the sample size, so the probability of type 1 error doesn't change. The answer is B. Number 5, 15 migraine patients are randomly selected from hospital records. Half the patients are told to drink ice water and sit in the dark when they next experience a migraine. The remaining patients are told to use neither of these possible remedies. Participants then report back as to relief, if any. Faults of this experimental design include all of the following except. So they don't specify randomization in the treatment. They did select the patients randomly, but they said half are told to drink ice water and sit in the dark. And the remaining patients are told not to do that. Part B, because we don't randomize treatments, there could be confounding variables. C, we're not sure that blinding is possible in this case because if you're going to try and treat it with ice water in the dark, you're going to kind of know if you do or don't get those benefits. So people can tell whether they're getting a treatment or not. Now, they didn't specify the amount of time or water. So I think one of the things they could have done is said, okay, 15 minutes in the dark, 1 glass of ice water or 8 ounces of ice water. They didn't do any of those things. And then no scale of relief is given. So how do you measure the response variable? So the only one that they probably couldn't deal with was the lack of blinding. Number 6, given 2 independent random variables, x with a mean of 12.3 and standard deviation of 0.5, and y with a mean of 9.1 and standard deviation of 0.3, Which of the following is a true statement? So we have our mean, which is 12.3 and 0.5 for x. So that means our variance is 0.25. We have our mean of y, and so we find out our variance is 0.09. So the expected value is just the expected mean of x minus the expected mean of y, which is 3.2. And you can see that that is not correct for A or B. We really can't take these to range, so we have no idea what the ranges are. So what we're going to do now is we're going to look at standard deviation or variance. So variance of x minus y is the variance of x plus variance of y. Remember, even though it's subtracting here, variances always add. And I add 0.25 to 0.09 and I get 0.34. And I can see that matches the answer for E. I could also double check standard deviation by taking the square root of 0.34, but I can assure you it is not 0.8. Number 7. Populations P1 and P2 are normally distributed and have identical means. However, the standard deviation of P1 is twice the standard deviation of P2. What can be said about the percentage of operations falling within 2 standard deviations of the mean for each population? So what I'm going to do is I'm going to use, first of all, this is not proportions. These are actual just populations. So it's unfortunate they're using the letter P. I apologize. So we're going to come up with a regular mean of, say, 92. And we'll say, okay, let's put a standard deviation on the first population of 10 and a standard deviation that's half that on the second population, which is 5. And we'll explore this with Staplett. So let's go ahead and look at the first population. The mean we said is 92. The standard deviation is 10. We plot the distribution. And they say what percentage falls within 2 standard deviations. So there's my mean, right? If I go 2 standard deviations down, that's 72. And if I go 2 standard deviations up, that's 112. And I can hit calculate area. Let me go ahead and label everything. So 2 standard deviations down to 2 standard deviations up is 0.9545. That should remind you a lot of the empirical rule that 2 standard deviations within the mean is about 95%. Now, that's population 1. Population 2 has the same mean, but the standard deviation is now 5. So I'm going to hit 5, plot my distribution. This time, when I go 2 standard deviations down, I'm at 82 instead of 72 because my standard deviation is half as much. I go half as far. And instead of making it all the way to 112, I only go up to 102. I go up 5 and another 5, 102, calculate the area, and I get exactly the same answer. So basically, I could just do the standardized curve right here. It doesn't matter that the population means are the same. If I am going 2 standard deviations down, which is basically a z-score of -2, to 2 standard deviations up, which is a z-score of +2, I'm always going to get this 0.9545. So it doesn't even matter how these means and standard deviations are related for different populations if you're always doing the same z-score, which is 2 standard deviations down to 2 standard deviations up. Number 7. Oh, so that means that our answer is the percentages are identical. That's always 0.9545. Number 8. A 2007 survey of 980 American drivers concluded that 38% of the driving population would be willing to pay higher gas prices to protect the environment. Which of the following best describes what is meant by the poll having a margin of error of 3%? So that the confidence interval is the point estimate plus or minus the margin of error. So it's 0.38 plus or minus 0.03. That means I need to calculate an upper and a lower. So lower is 0.38 minus 0.03, which is 0.35. And the upper is 0.38 plus 0.03, which is 0.41. So that means it is likely that between 35 and 41% of the driving population would be willing to pay higher gas prices to protect the environment. Number 9. Following is a histogram of the number of ties owned by bank executives. Which of the following is a correct statement? So I'm going to go ahead and divide this up and count roughly how many cells I have in it. So in that first column, I have 1, and then I add 2 more. I'm up to 3, 5, 9, 12, 15, because 12 plus 3 is 15. And then now I'm up to 18, and finally I get a total of 20 data points. So that should work pretty well, right? My median should be between data point 10 and 11. Well, those are all in this column right here. So my median is 6 ties. So you can see that A is not the correct answer because it says the median is 5. They also say that the more than 4 executives own over 8 ties each. But here I'm only counting 2 own more than 8. And by the way, it's kind of hard to tell because I don't know that these are actually a unit of 1. All right, then looking at statement C, an executive is equally likely to own fewer than 5 ties or more than 7 ties. So I count these up and I'm getting a count of 5. I count these up, I also get a count of 5, so that's looking true. 1 tie is a reasonable estimate for the standard deviation. I suspect it's higher than that because you can see it's probably a little over 1 tie. And then moving all the executives with 3, 9, and 10 ties may change the median. Since I actually took 2 out in front and 2 out in back, the median is exactly the same. Number 10, 4 pairs of data are used in determining a regression line. Y hat, or predicted y, equals 3x plus 4. If the 4 values of the independent variables are 32, 24, 29, and 27 respectively, what is the mean of the 4 values of the dependent variables? So they're looking for y bar. They gave you, we can actually calculate x bar, which is the mean of x. So we're going to add up the 4 values and divide by 4, and we get 28. Then we know that for the very special pair, x bar, y bar, the line must go through that point. So I'm going to go ahead and put x bar in there to get y bar. So I go 3 times 28 plus 4, I get 88. 88 is the mean of the dependent variable. Number 11, according to one poll, 12% of the public favor legalizing all drugs. In a simple random sample of 6 people, what is the probability that at least one person favors legalization? So the probability that X is at least 1 is the opposite of the probability that X is 0. So I'm going to go 1 minus the probability that X is 0. Well, the probability that someone does not favor it is 1 minus 0.12, and I have to have all of them not favor it, so I have to raise that to the 6th power. And you can see that matches the answer choice C. Number 12, sampling error occurs when? Well, sampling error is a natural part of randomness, and it results because we use a statistic to estimate a parameter. Bias is a different source of error. So the correct answer is B. We're using a sample statistic to estimate a population parameter. It is just the nature of the beast of statistics that we naturally have sampling error. Number 13, the graph below shows cumulative proportions plotted against GPAs for high school students. What is the approximate interquartile range? So IQR is Q3 minus Q1. Q1 is at the 25th percentile. So I'm going to start here very close to the 25th percentile and figure out what GPA applies there. Looks like it's just a little over 2, so we'll say 2.1. Then I've got to go find Q3, which is at the 75th percentile, and we find out that's very close to 3. IQR is the difference between those two, and I'm getting about 0.9, and the answer closest to that is 0.85. Number 14, in general, how does tripling the sample size change the confidence interval size? So we have the formula for your math chart, and now admittedly this could be for proportions as well, but looking at means gives us the idea. It's also an easier formula. So I'm going to say sigma of n is sigma over square root of n. Then I want to go to 3 times the sample size. So instead of n, I'm going to have 3n. So sigma of 3n is sigma over square root of 3n, and I can pull out the square root of 3. And in fact, I can say, oh, it's sigma over square root of n times 1 over square root of 3. And then basically that's just sigma of n divided by square root of 3. Square root of 3 is very close to 1.732. Number 15. What is the probability of a type 2 error when a hypothesis test is being conducted at the 10% significance level? Alpha is 0.10. Well, alpha only tells us the probability of type 1 error. We really don't have enough information for this question.